It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming You a Nice Coffee.
Hi guys, this video today is going to be all about ester hydrolysis. So hopefully you've watched the previous video which is all about ester formation. If you haven't done that, I suggest you do, okay? Because it's really important for you to understand how we make an ester, okay? By taking a carboxylic acid and an alcohol, okay? And using a acid catalyst and reflux, okay? Now when we're talking about ester hydrolysis, there are two types of ester hydrolysis that we can do. The first one is an acid hydrolysis, okay? And the second one is an alkaline hydrolysis. Now, if you don't know what alkaline and alkali is, an alkali is a water-soluble base. So basically we're doing one under acid conditions, one under alkaline conditions. So before I jump into it, it's really important to understand what impact these will have upon some of the substances you've got inside your ester mixture. Okay, so if you remember from the previous video, to make an ester, all right, you need a carboxylic acid plus an alcohol, all right, and it's in equilibrium with the ester and water. Okay, so that's our general equation for making an ester. What we're going to be doing is going with the back reaction. Okay, so when we do a reflux of this, of an ester hydrolysis, okay, what you're going to find is you're going to have a mixture of all of these substances within your pear-shaped flask. That's because it's in equilibrium. You never get 100% one way or the other in an equilibrium. Okay, so you need to understand about each of these different substances in here. Okay, the only one in here that is acidic or basic is the carboxylic acid, which makes sense. But that is really important to know depending upon the conditions that you're going with. All right, under acid hydrolysis, not surprisingly, you're going to get your carboxylic acid, okay? However, under alkaline hydrolysis, okay, you've got a base here, right? You've got a basic solution. What do bases react with? Acids, okay? And so under alkaline hydrolysis, you're actually going to get your carboxylate salt, okay? And what does that look like? All right, well, let's take a carboxylic acid. All right, let's take this one, propanoic acid, like this, okay? If you had an ester, something like ethyl propanoate, all right, and you do your reflux on this, what you're going to get under acid conditions is your propanoic acid, all right? Your hydrogen here is going to be protonated onto your carboxylic acid group. However, if you do it under alkaline conditions, okay, under alkaline conditions, your carboxylic acid is going to be deprotonated because this proton here is going to react with the base. And so what you're actually going to end up with is the carboxylate salt, which is this. All right? So it's like your normal propanoic acid, except this time it's what we call the propanoate ion. Okay? So we've deprotonated our acid, okay? And we've now formed the propanoate ion. Right, and that's really important to know. So I'll just show you two examples of the products we would get under each of these conditions. So I'll start with the acid hydrolysis. Okay. And I'll just show you an ester, what we would do, and the products that we would get, and how we would probably separate these out as well. Okay. So I'm going to start with this ester, okay? So I'm going to draw in my ester functional group there, okay? And I'm actually going to put in a benzene ring down here. So I'm actually going to use benzoic acid as the acid that we started with. And then for alcohol, I'm going to go with propan-1-ol that we use, okay? So here's ester. If we want to hydrolyze that, the term hydrolyze means to add water in. So we're going to add water into this, okay? And it's an equilibrium reaction. And for this first one, and I'll swap colours for it, for this first one, we're going to do it under acidic conditions, okay? So under acidic conditions, what we do is we break our ester bond, all right, which is this one up here. So that carbon to oxygen bond is actually broken, and we're going to end up with two halves. And if you want to know the trick to be able to do this, what I always do is I actually draw the ester out in pencil. All right, put a long bond between the carbon and the oxygen here, and then actually rub it out. okay? So that you can draw in your carboxylic acid. So there's the carboxylic acid we're going to get, which is benzoic acid, okay? And then we're going to get our alcohol over here, which is propan-1-ol. Okay, just written in the reverse direction, but hopefully you can see that these two would have reacted to give us our ester here of propyl benzoate. Okay, so that's under acidic conditions, that's pretty straightforward. Now, if we wanted to separate this out and actually get these materials, okay, as I said, at equilibrium, what we're going to have is a mixture of our propyl benzoate, water, benzoic acid, and propan-1-ol. Okay, now, to separate these out, this is insoluble in water, okay? This is insoluble in water, because even though it's got the carboxylic acid group here, okay, the carboxylic acid group is smaller compared to the big non-polar benzene or aromatic ring. So this is water insoluble. Ethanol and the water are obviously water soluble, so you have these two in one layer, these two in another layer. Okay? To separate it out, you would use a separating funnel firstly, get this out, and then you could do some distillation if you wanted the ethanol. To separate these two, all right, under acidic conditions, you then, in a separating funnel, kind of do the next step anyway, which is you'd add in some sodium carbonate solution. The sodium carbonate solution would turn this into a sodium carboxylate salt, which now makes it water soluble, so that could go into a new aqueous layer, okay? Then you could protonate it again with something like hydrochloric acid to get your benzoic acid back, all right? All that you will be left with in your organic layer is whatever propyl benzoate is left over. Okay, so under acidic conditions, you can see if you've got a non-polar acid, which is insoluble in water, you kind of need to do a alkaline step anyway, or a reaction with a base to make it water soluble to separate it. So what we normally do, okay, and I'll go to a different colour, so hopefully this will show up nicely for you, is we normally do our esters under alkaline conditions. So we use something like hydroxide ions. So we might add in some sodium hydroxide or potassium hydroxide, something like that, doesn't really matter. What we still get is our alcohol. Doesn't change at all that we still get our alcohol exactly as normal. But what it does do is straight away gives us the carboxylate salt here. So if we were using sodium hydroxide here, right, we get the sodium carboxylate salt of our acid. Now what that means is that at the end of our ester, we've now got an inorganic layer, all right, so this non-polar insoluble in water layer of the ester, and then we've got our propan-1-ol and our acid, which are both in the aqueous layer, okay? So what that means is we could then go through, distill off the alcohol straight away, and then reprotonate this by adding in hydrochloric acid, which would reprotonate that, probably crystallize it out of solution, and then we've separated everything. So doing it under alkaline conditions makes it sort of one easier step, all right, in terms of you don't have to go through and then do the reaction with the base in the separating funnel. You've normally got it straight away. All right, so hopefully this has helped you out in terms of understanding the products of acid hydrolysis or alkaline hydrolysis. Remember, the only difference comes down to the carboxylate ion or the carboxylic acid, depending upon which way you do it. You can still affect the rate and the yield and everything like that, similar to the previous videos, so make sure you go back and have a look at that, of how you could perhaps increase the rate of your hydrolysis of your ester by using reflux or heat, use a catalyst, or increasing the yield of your products by using, perhaps boiling off the propan-1-ol as it forms. That might be an option as well. Alright, as always, if you've got any questions, just ask, but really use these two videos together. Make sure you know all about esters. Thanks, guys.